Alright, welcome back for one of our last videos on factoring. We're going to factor special cases of our perfect squares. So we got to remember all those numbers that are perfect squares, such as 1, 4, 9, 16, 25, 36, 49, so on and so forth. So let's take a look at these two cases. First one is called the difference of two squares, so x squared minus 9. Let's do our normal factoring. What's interesting here is not a trinomial because it's missing the b term or the middle term, so it's just a binomial. So what's really in front of the x squared is a 1, which is again a perfect square. So what we do is split that up into two binomials. X squared becomes x and x. And then what is the square root of 9? Well, 3. In this case, we'll put positive 3 and negative 3 because those will cancel out any b term in the middle. If you put plus 3 and plus 3, you get 6x as your middle term or your b term. Or you put minus 3 and minus 3, you get negative 6 as your middle term. Here, if you do positive 3, negative 3, then it is going to cancel out and give you 0x. Alright, you try. Try x squared minus 16. Press pause, and then we'll come back and check it out. So you do the same thing. Oh, well, okay, welcome back. If you got x plus 4, x minus 4, then you've got this. So try again. Try 4x squared minus 25, where you now have a term, coefficient in front of x squared. We look at the two numbers, 4 and 25, and notice that recognize that they are perfect squares. So in the two binomials, the 4x squared will become 2x and 2x. So a negative 25 will become plus 5 and minus 5. So in the end, your b term will cancel out with 10x and negative 10x. You try 36w squared minus 81. Split it up into two binomials. 36 is a perfect square. You'll get what? Yes, 6 and 6. A negative 81 will split up into positive 9 and negative 9. Bam. Last one, 64z squared minus 49. 64 and 49 are perfect squares, so we get to do the bit difference of two squares. 64 will break up into 8 and 8, and 49, or negative 49, will become positive 7 and negative 7. Alright, hopefully you'll recognize perfect squares, the difference of two squares from the beginning. Now let's try perfect square trinomials. Okay, what if you do have a b term in the middle? This is what we do. Split them up to two binomials. X becomes x and x, or x squared becomes x and x. 25 will be positive 5 and positive 5 to give us positive 10 in the middle as your b term. And then we'll write that even more cleanly and succinctly by writing x plus 5 squared. Quantity of x plus 5 squared. You try now. Try x squared plus 18x plus 81. The whole idea here is to recognize that, well, 81 is a perfect square. Okay, so you give that a shot. Okay, welcome back. X squared is x and x. 81 will be 9 and 9, both positive, and they'll add up to 18x in the middle. And we rewrite that as x plus 9, quantity of x plus 9 squared. And now try 4x squared plus 20x plus 25, and we recognize that 4 and 25 are perfect squares. So 4 will break up into 2 and 2, 25 will break up into 5 and 5. And we test it out. 5 times 2 is 10 and 10, and that will give us 20 in the middle. And we rewrite that as quantity of 2x plus 5, all of that squared. Last one, let's try 16x squared plus 24x plus 9. Recognize that 16 and 9 are perfect squares. Let's break that up and see if that works. 4x and 4x, 3 and 3. But we have to test it out. Does 3 times 4 and 3 times 4, do they all add up to 24? Well, 3 times 4 is 12. 3 times 4 is 12. Together, they add up to 24x in the middle. And we cleanly write that as for quantity of 4x plus 3 squared. Alright, hopefully this will help in our factoring journeys if we can recognize our perfect squares. Alright, thank you very much. Bye.